Hey everybody, this is David Mars with Mars HVAC Services and Mars HVACR Design School. And today I'm still working on that commercial building, that really small light commercial. And what I've done is I've finished the drawing or the drawing of the just the structure. I haven't done the duct layout yet or anything like that. But my next step is to choose what equipment to go for. I know this one's going to be carrier equipment. So let's go over to the equipment screen. Actually, first let's go ahead and check out our load. I always like to look at loads and the short form. And then I'll take a look at my BTU amounts that I have here. Now remember, we got our square feet of 1720. That's our heating. And this is our cooling. So we're at 44,427,000 or 427 BTUs for the sensible, and our latent is at 10,721. So right there I can tell you we're within a 5-ton range, and so we're going to go ahead and roll on that. So let's go ahead and choose the equipment. We're going to do a heat pump, and for carrier, I really like to use the 25HCC5 with an FX4 DNF. That one I find to be really good. It's I've never really heard any complaints out of it for the installation from companies that install, but I just find it to be a good unit, and it's really good with energy efficiency. So let's go ahead and type that in, 25HCC5 with an FX4D. All right, so we have two choices here. Actually, they're both the same exact one. All right, now I'm going to go ahead and set my static pressure at 0.5. And everything else looks cool. We got that 5-ton. It showed that it was going to work for it. It looked like it was going to work good. And we're also going to double check another area too to make sure it's going to work and that it's fine for this building. So we got that complete. Let's go ahead and let's look at this report one more time. So our sensible is going to be 44,427. And our sensible is capable of 45,600. And we have a latent of 11.4. Now remember, I changed my SHR, the sensible heat ratio, to 0.8. We can change it back to a 0.7. Typically, it ranges between a 0.7 and a 0.8, and there's several variables that are factors in that. But at the end of the day, when you're doing your design, half of whatever your remaining latent can be converted back over into sensible. So if we did it as a 0.7, then you can go over and take your remaining latent, put it back over to your sensible, and as long as you fall within those parameters, you're fine. And when I do a commercial design, I always like to make sure that my sensible and my latent are both sized with the unit. I know in some areas of the country, I'll do that with the residential as well. If I was to do this in Florida, Florida building code states that it's the total in the latent. So the sensible isn't worried about as much. In Florida, we're worrying about that moisture removal inside of a home, and then we're also worried about making sure that the overall capability of the unit can satisfy any type of requirements that the home has. But that's on residential. Commercial is a completely different monster, so that's why I like to be able to do make sure that sensible and latent, and we fall within all those parameters. And so we do. It looks great, and I'm going to go ahead and move on from there. So let's go back to our draw screen, and I'm going to start moving ducts around. Let's go ahead and put this in the mechanical room now. Another thing I'm going to do too is move these room names out of the way. Room names are great, but they typically, if they're right in the middle, they're in the way of everything that you need to have done. And let's get that hall out of there. And the mech room. All right. So now let's go ahead and just put a basic preliminary setting of the duct, where the ducts are going to be located at. So we have that there. Now these rooms, let's go ahead and just measure these real quick here. All right, so we're looking at 14 by probably close to the same, about 16. Now when you start getting into like the 16, when you're over 16 feet by 16 feet, I always recommend to have 2. We don't really have any type of load-bearing areas except for the internal gate in this particular building, in this situation. So I'm going to go with just 1 drop in each one of these, and then our second drop will be our return in each one. And I'm going to put that right there by the back door. Our main return, of course, would be, if we read our note on our print, it's going to be through the unit, and it's going to be a louvered door. All right, so let's put that there. Now the break room, that's where we had some extra loads in there, so I'm definitely going to keep 2 in there, but I'm not going to put a return inside the break room. Most areas, building codes specifically say that returns are supposed to be in main areas, and they can be in some transient areas, but areas such as break rooms, you really don't want to do that because you'll get a lot of the smells from, if somebody burns popcorn, it's going to be everywhere inside the entire office and make the office a really not too fun place to be in. All right, so now I have that set up. Let's go ahead and we're going to set up the static pressure here. Make sure this is cool. Now with this, there's more than one way to skin a cat. Many people use different things. People will use 0.05, 0.03. I like to use 0.03. And then for the filter, let's go ahead and use 0.1. All right, now typically your available static pressure should be between 0.3 and 0.4 by the time that you do your pressure losses. I've seen a lot of times where people put the coil in there, but if you go through and you read your manual D and you read a lot of the different literature, your coil is often included in there. It's the same thing when you do your heat load calculation. Your blower fan heat is actually incorporated in the capacity of the unit when the capacity was being established for the unit. You'll see a lot of people will add more BTUs for that blower fan, and it's completely not necessary. You're being redundant at that point. And the more redundant you're being with adding extra stuff into it, the less accurate you're being on your load. All right, so we have that done. We went ahead and we set our static pressure. We have that complete. Let's go to our duct preferences. Now on this one right here, we're going to be I'm going to choose the flex junction box, but I'm going to change the trunk to fiberglass duct board. Like I said, this is light commercial. It's not anything overly complex. It is in Florida, so flex and duct board are very standard in Florida. Because I don't want nobody getting their panties in a bunch going, duct board, flex, it's evil, you need to have metal. Some areas in Florida, you have metal and it's going to become a rust bucket. It's going to corrode faster than ever. All right, so we have that complete. We're ready to draw our duct layout now at this point in time. So let's see. We are going to make some loop overs. So Office 1, Office 2, and Office 3. We'll have loop overs that go into the hallway here. And then I'm going to make one big trunk line heading straight down this way. There we go. So now we have that there. Now I'm going to go ahead and throw a return in, but I'm going to change that sucker so I can make a loop over. Oh, and we had the back button. There we go. All right, so now what these will do is these are going to be like a 24-inch tall cap. Sometimes it can be 16-inch tall cap. Made out of fiberglass duct board. They extend up, and then they're going to have a collar coming out the side to another tall cap over here. And then that helps with sound attenuation, and then it also, it's, you know, when it's sized and you size it correctly according to Florida Building Code of the diameter being, of the volume of the diameter being 1.5 times the size of this incoming supply, then it makes it very, very efficient and a good mover of air out of that room. Now, the best way is always having that remote return, but you're not always going to get that. Sometimes you got to work with what you're given. And in this particular situation, this is what we're given. All right, so I have that complete. Now I'm going to go ahead, I'm going to hit this little button right here. It's connect registers to ducts. All right. Now, as you can see, it connected a bunch, but I'm going to have to do a little bit of corrections here. So let's bring that down. Now, if you can see that pop up right now, that is because I have right proposal. So it's asking me what type of fitting I'm wanting to use if I was going to be working up a bill of materials on this. I just want that to look like a nice round edge there. And this one, I'm going to bring this up here and then have it connect right over here. All right, so we have that complete. Now, let's go ahead and turn on our duct notations, and let's start seeing what sizes we got. And I'm just going to move some of this stuff out of the way so I can get a better grasp of what's happening. Because now I'm going to start putting reducers in here. And then it's wanting me to show it as round, and this is going to be rectangular ductwork, so I'm going to have to go in and change that as well. So what I'm going to do is I'm going to throw one there. I like to reduce a lot because what I like to do is I like to have that pressure push the air to the rooms. I like if you just stick with a one size going all the way through, that never works. All right, so it looks like we got 9 inches, 10 inches in the one. Now that looks pretty good. All right, now let's go ahead and start changing these out from round to rectangular. All right, oh, let me change that to there. Perfect. All right, that looks good. Now, I'm going to size these up. Another thing I'm going to change too, these are going to be 24 by 24 because they're going to be, well, not all of them. I'm just going to leave it square because I don't want to show the sizes on those. But these will be the 24 by 24. There we go. Now if that's going to be 10, this is going to need to be 12. That's going to need to be 12. And that one will need to be 12. All right, we have our ductwork done. And now I'm just going to go ahead and let's go ahead and do drawing, and let's do it at 2. 2-line drawing always looks way more professional. So now we have almost an AutoCAD quality. I'm just going to space everything out so it's easy to read. All right, and there we go. That is it. I have that complete. I have the return showing in there. And then there's also going to be the notation of the return going through the louver door. And then there's going to be a grill on the bottom of the unit for the return for this particular situation. So this is finished for getting the ductwork done. My next step from here will be to take this and go ahead and put it in the AutoCAD. So what I'm going to do is I already have where there's the AutoCAD in the background. So now I'm going to go to Drawing. Let's show the AutoCAD and Drawing. And we're going to write to AutoCAD files. And I'm just going to do the ducts and duct notation. Oh, that's because I have it open in another. Okay, well, what I'll do is I'm going to create a whole nother video. But the issue with that was I have it open in another software. I have it open in RightCAD. And so, actually, I'll do this real quick. Instead of doing another video, let me, right now I'm off screen. There we go. Now I'm going to come back on the screen. There we go. And let's try it again. There we go. And it did it. So now in my next video, I'll be going over and being in RightCAD, and we're going to go ahead and finish this up by drawing up actual mechanical documents where it's going to have schedules, notes, and details. We're going to make it look really good on it, and it will look like it, you know, what a typical blueprint fashion mechanical drawing would look like. Alrighty, y'all. Thank you for watching.